All right. Hey, starting a new um group of vertebrates today. Um, we are going to start our reptile unit. Now, this isn't the Minnesota Reptile ID. This is actually a little bit of kind of reptile, kind of some of their basics of anatomy, physiology, behavior, lifestyle, all of the above there. And we're going to start off with everyone's favorite, and those are the dinosaurs. All right. When we talk about evolutionary history, um, I always like to start with fish, kind of the oldest vertebrates, then amphibians, kind of showing that next step onto land, into a bigger world, and then end with dinosaurs, which are finally the link has been broken from the water. Okay, so when we talk about reptiles, we always got to talk about dinosaurs because they were some of the first reptiles. Their evolutionary tree is messy on where they ended up, but we identify with them as reptiles, and as we should. And these were the first vertebrates to really dominate the land on Earth, and did so for quite some time. Okay, did so for quite some time. Age of the reptiles. Ooh, hold up. There we go. Um, the first reptiles appear in the fossil record 315 million years ago. So if you think about amphibians, were 375 million years ago. So 50 years of since Tiktaalik, that first thing that walked on land, we start seeing the reptiles and then the reptile dominance on land. All right. So think about when we talk about evolution, evolution takes time. All right. It takes time. It takes a lot of time for those small changes to happen. We'll get into what those changes are. But we call this time the period the Mesozoic era, and is marked by three separate deals: the Triassic, Jurassic, and Cretaceous. You've probably maybe heard of those before. For sure, you've heard of Jurassic Park. Cretaceous is the most recent one. All right. And that's the one that is, oh, where's the, trying to have the date. Oh my gosh. And there's that's the one, 65 million years ago. All right. So roughly 65 million years ago is when the Cretaceous period ended. All right. That is the end of the Cretaceous period. And we marked the end of the Cretaceous period at this asteroid event. All right. Um, in the Yucatan Peninsula in Mexico, there is an impact site that shows evidence of an asteroid that was 6 miles across striking the Earth. All right. What does that mean? Well, it means that all those dinosaurs that lived on that spot that day had a pretty bad day, but they'd probably vaporize, instantly. Um, what it means for the rest of the planet is just the sheer amount of energy that hit the earth with. It's almost like the earth getting hit with a gunshot is what it is. All right. 6 miles in the grand scheme of the earth is not a large distance. All right. That wouldn't even that's smaller than the distance between the twin cities. However, something that's 6 miles traveling faster than any bullet from any gun on Earth hitting the Earth creates a ton of energy. How much energy? This is from Neil deGrasse Tyson's book, the Space Chronicles. We talk about how large asteroids are and then the impact of their energy. And then we like to compare it to, one of the biggest sources of energy that we know, and that is, atomic bombs. Uh, Asteroids are 3 meters in diameter, so about 9 feet. How often do they hit the Earth? They actually hit the Earth about monthly. Okay, so monthly asteroids that are a couple feet across will hit the Earth. Remember, the Earth is mainly water, and so it doesn't not a huge impact. And a lot of times they'll break up in the sky. They're small enough that they will not make it to the surface. Their atomic energy equivalent is 5% of an atomic bomb. We work our way up into some of the bigger asteroids, and we can see that they hit the Earth a lot less frequently. There's fewer of them floating around. There's a lot more little small pieces. Um, Here we get to the impact that would have wiped out the dinosaurs. An asteroid 10,000 meters across, that's the size, the one that they estimate hit the Yucatan, would deliver approximately 5 billion atomic bombs worth of energy. Okay, it wouldn't be necessarily the nuclear radiation, but would have caused huge problems as they're going. Um, so a blast of that megatons, whether on land and sea, will lead to mass extinction on the scale of that impact, and where roughly about 3/4 of the Earth's species were wiped out. All right. Um, I always like to throw this quote on there. Right now, if an asteroid of that size is going to hit the Earth, what would we do to stop it? We have no plan. As a species, we have no plan if an asteroid that big is going to hit the Earth. We would frantically try to put something together. But maybe that's something that, hey, we maybe should like try to start thinking of a plan on how to come up with that and maybe build some tools as that's going. But anyway, how does that relate to our dinosaurs? Like I said, that wiped out the major dinosaurs. We obviously still see a lot of reptile species that made it through that. Usually the smaller ones did better at the time. But here's a little look at that evolutionary tree and the variety of dinosaurs that we saw. We saw crocodiles still living back then and surviving the impact and um, um, living to this day. We'll get on to, spoiler alert, that birds actually branched off of some of those early dinosaurs in there as well. And we'll see there's still some of their um, commonalities with modern reptiles in there as well. One of the biggest things that we talk about with reptiles and dinosaurs is their hips were built different. Okay, a modern reptile, its hips are and its arms are sprawled out. I think of any lizard that you've seen looking from above, any turtle, any of that stuff, and their legs are out kind of like sprawled, all right? Versus dinosaurs were more like mammals, where their legs were underneath them. I think about looking above a horse. You're not going to see its legs out to the side. That'd be kind of creepy. Its femurs were directly underneath mammals, and that gives us an advantage. We can grow bigger that way because of how the weight's distributed. Dinosaurs were the same way. Their femurs were below their pelvic girdle, so they could grow taller. They could support more weight as they're going. The reptiles that survived the impact tended to be of this sprawling nature, so their femurs were splayed out. They were smaller in size as they're going there. So dinosaur and reptile hips, one of the biggest differences between them, why many of those bloodlines died that day, or that it was a couple years worth of dying out when that asteroid hit there. So anyway, starting off dinosaur or reptiles with a little bit of their evolutionary history, and that should be good for this part one lecture.